Okay, so yesterday we have seen the three major functions of a switch. The functions: address learning, frame forwarding or filtering decision, and loop avoidance. So we saw yesterday two. Today we will see the third function. This is how does a loop occur and how will it be prevented. So assuming a scenario wherein you have two layer 2 switches over here, and these two switches are connected with each other in a redundant fashion. Yesterday we created a trunk link, isn't it? So what will happen if you have a trunk link? This trunk link is a part of all VLANs, isn't it? And we have hosts who are connected from here to here. So this is my PCA, first PC. This is my PC2, and this is my switch 1, and this is my switch 2. This PC will send out some data, and this data will be received via this switch. Now, if the switch has multiple ports, assuming that this is a trunk port and this is also a trunk port on both the sides, these two ports are trunk ports, and this PCA sends out a broadcast. If a broadcast is received on a switch's frame, on a switch's interface, it will send out on all the other available interfaces except the one it has received it. It will not send it back over here. It will send out on this interface, and it will also send out on this interface. Now, see what happens. If this frame is received on this switch, it will be received on the switch, and the switch will forward it over here. It's okay. It is a broadcast, but this frame is a broadcast frame, and it has to be forwarded out on all the other interfaces. So this frame will go back on this interface. Now, the first function of a switch was to learn the addresses. So your device will learn the address. Okay, he switched to learn, assuming that this is my port number 1, port number 2, port number 3, port number 4, port number 5, and port number 6. Now, if a frame enters this switch over here, this switch will update its CAM table saying that I have on my fourth port PC1 sitting over here, PCA or PC1. He will update his CAM table, and the moment he sends out, the moment he receives another frame also, for example, this frame will also come in over here. He will say, oh, I have Mr. A. He must have been relocated. So Mr. A is sitting on my 5th port now. So PCA is sitting on this 5th port. So what happens is this is instability. This is going to have instability in the CAM table, and end devices will receive duplicate frames. This guy received two frames because of one link and another link. Now what happens is, this is okay, this can be variable, because if this guy receives 2 frames, it's a different story. But what will happen is, if we see what happened over here, this switch received a frame over here, he also sends it back over here, and he receives a frame. If I say he receives a frame on this one, he sends it over here, and he will send it over here also. Now what will happen is, the frames that are revolving over here, it will create a broadcast storm. How a broadcast storm is created? Because of redundant links. And in an IP packet, there is something called a time to live field. A TTL field is there. Time to live of a packet is 255 hop counts. So if you say an IP packet crosses 255 hops, it will be discarded by the router. But this TTL value is not there in your layer 2 frames. So that is the reason this frame will endlessly be revolving on the devices. And this is a story of 2. If there were many switches, then it can be very dangerous. So earlier there were switches who could not bear this, but nowadays your switches are very fast. But eventually there will be a time when the processor will go high and high, and the device might go off. So to avoid this kind of looping situation, Radia Proman created a protocol called Spanning Tree Protocol, STP. Now, what will STP do? Spanning Tree Protocol will detect redundant links, and it will block one of the link. For example, if I say this is my redundant link, I will block this link. And so the data goes only on one interface, and it is going to go back on this interface. So to avoid your layer 2 loops, you can say spanning tree protocol is very helpful. Now here we are talking about common spanning tree, CST, that is IEEE standard 802.1d. Now what will happen is in this situation, so if these are two switches, it's okay. But if you say, let us create another topology. Let's say over here, if I have multiple switches, switch number 1, switch number A, B and C, and they are connected in this kind of fashion. Okay, now in a situation like this, which link has to be blocked? For example, if this is my switch A and this is my switch B and this is my switch C, every device, okay, we'll discuss about every device has its own MAC address. That MAC address is called the base MAC address, and that can be seen via show version on your iOS. Now what will happen in this scenario? This device will send out a broadcast on both the links. This broadcast is sent via him over here, and this broadcast is sent to him up. The broadcast received on this link is also sent via him over here, and this is sent by him over here. So the broadcast goes on happening, right? So it's a broadcast storm created. And how will spanning tree avoid this kind of situation? In a situation like this, spanning tree does something called an election. And understand one thing, these switches will send something called BPDU, Bridge Protocol Data Unit, after every 2 seconds. It's like the boomerang of your Mowgli. He used to send a boomerang, and every device will send a boomerang over here. They will keep on sending boomerangs after every 2 seconds. Now, in a design like this, or if you have any design, spanning tree will build a triangle type of topology. Herein, they will do 3 things. First is they will elect something called a root bridge. Elect the root bridge. Second thing, they will find the best path to it. And third, they will block the others. Block the other links, you can say. Now, how will this election take place? This election will take place on the basis of the bridge ID. Now, a switch evolved from an Ethernet bridge, so we also call it multi-port bridge, as we saw previously. So what is the components? What will be the factors that a device will use for him to participate in the election? This bridge ID consists of, in common spanning tree, it is of two things. One is the priority, and the other is the MAC address. This MAC address is the base MAC of your switch, you can say. Now, here it is lower the better. If you have lower MAC address, you will win the election. The priority by default of all the Cisco switches is 32768. You must remember this number. This is by default on all the Cisco switches. So this is the value that all the switches will have. So priority comes to a clash. Every device has the same priority. So these priorities will be same. What will be the calculating point? It will be the MAC address. So whoever has the lower MAC address, he will win the election. Now, this spanning tree root bridge, he becomes the root bridge. For me, this is the root bridge, and a root bridge will have all its ports in the designated forwarding state. There are port roles and port states. These 2 ports, all the ports, understand one thing, a root bridge will have all the ports always in the forwarding state. He will not shut down any state, any port of his. Now, this becomes the designated port, and this is in the forwarding state. This is my designated port. This is in the forwarding state. This is again the designated port, and this is in the forwarding state, you can see. Now, first thing is done, root bridge is elected. Second thing is to find the best path. Now, these other non-root bridges will find the best path. How will they find the best path? If you remember OSPF, there is link cost associated with every link. 100 Mbps will have a cost of 19. 1 Gbps speed will have a speed of 4. 10 Gbps link will have a speed of 2. Assuming a scenario wherein the speeds over here is, for example, it is 19 over here, it is 19 over here, and it is all are using fast Ethernet cables. So from device B's point of view, this port is the fastest way to reach the root bridge. This port is in the designated, and it is in the, now this port is a root port, you can say. So it's like the road that goes to the parliament is the parliament road, right? So this port, the port that takes me to the root, the port that I take to the root is called the root port. So on this every segment there will be one root port. So this device says, okay, if I go via this path, if I choose this path, it will cost me 38. So instead of 38, I choose the best path. So for both of these switches, the root bridge is reachable via this port and this port. So these ports will be termed as your root ports. This is my root port and this is your root port. So what will happen in this segment? Now both of us have elected a root port. Find the best path is done. Second is to block the other links. Now in here, one has to block, and Kurbani dega kaun, right? Who will block the link? In between these two devices, the device that has the higher MAC address will end up blocking his link. The device that has the higher MAC address, he will be the one who is blocking the link. Right? Getting the point? This is the behavior of your common spanning tree protocol. Now, what does Cisco do is, Cisco uses some other mechanism. As of now, what happens is in common spanning tree, this whole link is not being used for any data. No data is going to be passed over here. And what if you say, I want to use it? Now, what Cisco created was something called per VLAN spanning tree, PVST, per VLAN spanning tree. What does per VLAN spanning tree do is, they will elect a root bridge for one VLAN. You can choose. You can say, this will be the root bridge for VLAN 2. So for VLAN 2, only this port will be blocked because this is the root. This is my designated root port, and this will be blocked. And you can say, okay, this device is the root for VLAN 3. Now what will happen is, this device is the root port. These two ports are my root ports. Again, so these two ports are my designated ports. This is the root port. This is the root port. This port will be blocked because between them, this has the higher MAC address. This port will be blocked for the data of VLAN 3. So this is better than common spanning tree. Why? Because it uses one more parameter. You can say it uses something called system ID extension. System ID extension. It is system extension ID, system ID extension. It uses the VLAN number. Simple as that. So if you see the spanning tree priority on these devices, it will say the spanning tree priority is 32769 for VLAN 1 and 32768 plus 2, you can see. So you can decide which type, which switch will be the root bridge for which VLAN. So this port will not forward the data of VLAN 2. This port will not forward the data of VLAN 3. So it is better than common spanning tree. Why? Because here the whole link is not being blocked. It is at least being utilized for other VLANs and also avoiding the loop. But understand one thing, spanning tree, this per VLAN spanning tree has one instance per VLAN. Means one instance per VLAN means if you say VLAN 1, then it will send out BPDUs per VLAN. For every VLAN, he will have root bridge, root ports, forwarding ports and all, everything, every calculation has to be done, right? So if I say there are 1000 VLANs, how many instances will be there? There will be 1000 VLAN instances. This is a little processor intensive, you can say, but this is better than common spanning tree. Instead of, and we can choose. Now, by default, Cisco switches will run per VLAN spanning tree. It will say IEEE, but it will run PVST. Let me connect these devices over here. And let us see who becomes the root bridge and What are these two other devices? Now, if you say, just assume one thing, that the device is over here. For example, I'll just get rid of all these things. If I say I have 3 switches and this is elected as a root bridge, oh wow, that is a good thing. But if this is my Cisco Nexus 7000 brand new shiny switch over here and he has a higher MAC address, what will happen is, this is my 3560 switch. If it's my layer 3 switch, it's okay, but this is a fairly small switch with 68 ports or something, 48 ports or 24 ports. But this switch will end up becoming the root bridge always. Why? Because this has a lower base MAC address, right? And if this old switch becomes the root bridge, everybody will take path for via him only. Spanning tree creates a loop free path. Everybody will take this path. So it is not feasible to have it. It is not good to have an old device to be elected as a root, because priority is same and MAC address wins is the one who will be the deciding factor. So you can also change. If you say, I want this latest device of mine to be the root bridge, you can do that, and it is recommended always. So you cannot change the MAC address. What can you change? You can change the priority. So if you say, I want this device to be elected as a root bridge, I will change the priority, and I will change the priority lower than 32768. Let us see. Just understand, we'll see switching formats. 802.1d, this we were discussing earlier, but now we are discussing PVST, ParVLAN spanning tree. Let's go back on our switches. Let's see. See, you can also understand by seeing the diagram here. This diagram says 2 ports forwarding, and the port that goes to the root bridge will never be blocked. So again, this must be having the highest MAC address. Let us see. If you click on the switch, and if you say, okay, let's enable show spanning tree. Spanning tree tells us this is IEEE protocol IEEE, but it is running ParVLAN spanning tree. Why? Because it has 32769 as the priority. See, it says, I am the root bridge. Every 2 seconds, I will send out a hello, max age and forward delay is 15 seconds. System ID extension is 1. So the priority by default is 32768 plus 1 is the VLAN number. Right? So that is the reason it says priority is 32769. And see, this is the ID of the root bridge. This is my ID. This will be same on this device because I am the root bridge. All these devices will send out this VPDU. They will say this is the root bridge's ID and this is my ID. For election purposes also, they will exchange their VPDUs and understand what is your ID and what is my ID over here. So let's see, both the ports of your switch are in the designated mode and they are in the forwarding state. Always understand the roles and the states. Let's see, this is my switch 1. I'll just give it a host name, switch 1. Let's see the switch 2. This is my switch 2. Enable show. See here, if you see while it boots up, it should show you the base MAC address. See, this is the base MAC, it tells you. While booting, if you say show version, include command doesn't work, but here it says base MAC address is here. So we can say configure terminal host name is switch 2. Do show spanning tree. Do show spanning tree will tell, okay, this is the root bridge's ID and this is my ID. Here if you see, why did he become the root bridge? Because he has a lower MAC address. He starts with 0001. I start with 0009. That is the reason I lost the election. Priority is same. Okay. So priority cannot be compared and that is why the MAC address is being compared over here. And see this port, my F0/1 should be going towards the root and that is why it is in the forwarding state. This is a fast Ethernet link. So if you see F0/1, it should be connected to the root bridge over here. If you see F0/1 goes upstream. If you want to see by this also, you can also use a very helpful command, show CDP neighbors. This is Cisco Discovery Protocol, Cisco proprietary. The open standard protocol is LLDP, Link Layer Discovery Protocol. CDP, Cisco Discovery Protocol, will tell you about which device is directly connected to you. It says, I am switch 2. I have switch 1 connected on my F0/1, and he has connected me to his F0/1 interface. This is a very helpful command. In production times, it is going to come in handy. So show CDP neighbor will tell us, okay, so we can see which device is connected. It is the switch 1 that is connected to my F01, and that is why he is the root bridge. And this is the path that I go and connect with him. There is another switch on F2, and he is also connecting me to his F0/1. See, these are my ports. My F0/1 goes up. My F0/1 goes up. My F0/2 goes to this guy. Let us see on the third switch. Enable show spanning tree. It says the root bridge's priority is this. His MAC address is this. This is my priority, and this is. So why am I the last? Because 00E is what? So it is 14 if you see E, and the other guy is 9, and this guy is 1. If you compare the MAC address of this and this switch 2's MAC address is 0009. So switch 1 has the MAC address of 1. Switch 2 has a MAC address of 0009, and switch 3 has a MAC address of 00 or 14, you can say. That is why he has his F0/1 in the alternate blocking state. Alternate means it is the alternate path going towards the root, and this is in the blocking state. I will just give him a host name. So now what happens is, let us say that I want to create 2 VLANs, and for 1 VLAN, so this guy will be the root for VLAN 2. This guy will be the root for VLAN 3. Let us create first some VLANs. Let us say notepad, enable configure terminal. How do you create a VLAN? VLAN 2, exit VLAN 3. Done. That is how we will create the VLANs in the global configuration mode. And it is always important to configure your trunk links. There is dynamic trunking protocol that is going to happen, but as of now, I will say interface F0, interface range, I'll say interface range F0/1-2, switch port mode is trunk. Why trunk? Because a trunk link will carry the data of all the VLANs, and that is the reason. So if I say, see, what if I do not do anything? Control C, I'll just create the VLANs on all the 3 devices. How do you create it? Simply go and push these commands, enable config key VLAN 2, VLAN 3. Over here also. As of now, let's go over here. Let's say show spanning tree. Spanning tree here, it shows I am running spanning tree only for VLAN 1. But I said per VLAN spanning tree has 1 instance per VLAN, but he is not running any instance for any VLAN. What does this mean? This means that this VLAN, if you say show VLAN brief, as of now there are VLANs created, but spanning tree is not running for these VLANs. The reason being, spanning tree will run only if you have an interface connected into it. So you have to put an interface on that, or you must have at least 1 trunk link configured. So that is the reason I did not push this command. If I go and push this command, Control C, I will configure 1 and 2. See, why am I saying 1 and 2? Because 1, 2, 1, 2, 1, 2. Same command on all the switches. So configure terminal, and please configure 2 devices as trunk ports. I am forming manual trunking. Switch port mode trunk. Sorry, it seems my packet tracer crashed. I'll be back in a moment. Okay, so we are back again, and now let us see. This switch becomes the root bridge. Show spanning tree. This is the root bridge, and he has both ports in the forwarding state, but spanning tree is not running in here. Show spanning tree for VLAN 2. As of now, see, why is it running now? Because I entered the switch port mode trunk command. If you do not give a trunking command, spanning tree will not work, because by default all the ports belong to VLAN 1, and that is why it was only working for VLAN 1. The moment I created a trunk link, a port belongs to that VLAN, and because of that, spanning tree has to run. So if I simply say show spanning tree, see what will he say? I entered show spanning tree over here. It says this is the database for VLAN 1, you can say. One instance per VLAN. And this is the data for VLAN 2. So I have, see here, 32768 plus 1, 32768 plus 2. This is for VLAN 2. So this is also a root bridge for VLAN 2 and VLAN 3 also. This is for VLAN 2, this is for VLAN 3, and this is for VLAN 1. So I am the big daddy of the network. He is the focal point for all root. So this is same like common spanning tree, but I say this port, this switch should be the root for VLAN 2 as decided. Do show spanning tree. So he says this is the root bridges ID 005 something 006. So what I'll do is I'll say spanning tree VLAN 2 root primary. There are two commands that allow you to change the root bridges selection. One is in the global configuration mode. You should say spanning tree VLAN 1 root primary, spanning tree VLAN 2 root primary, or you can also say spanning tree VLAN 2 priority. But understand one thing, priority can be only in the multiples of 4096. 4096. So if you want to change the priority, make sure the number is in the multiples of 4096. Let us do this on one device, and let us do this on the other device. What I'll do is I'll simply take this on switch 2. So this becomes the root for VLAN 2. So if I am on the switch 2, I will say show spanning tree. He will show me the spanning tree instance for VLAN 1. He says this guy is the root bridge, but for spanning tree VLAN 2, I am the root bridge. Power of your power per VLAN spanning tree, because I can choose now. As per decided, this switch becomes the root for VLAN 2. So this guy is a root for VLAN 1. This guy is a root for VLAN 2. This is VLAN 1. This is VLAN 2. And this will be for VLAN 3. That is how you can create. And accordingly, spanning tree will calculate. See, this is for VLAN 2. Okay, this port is blocked somehow. And if this is the root for VLAN 2, then this port is blocked. Somehow it will calculate. And if this is a root for VLAN 3, okay, root port, this is high, this will be blocked. Why? Because this is root port, this is root port, block others. So this has a higher MAC address, this will be blocked. So let us go and configure this device to be root. Configure terminal, spanning tree, VLAN 3, priority. By mistake, if I say priority any number 3, it says sorry, you cannot do it. Will be the bridge priority must be in the increments of 4096, and it helps us. It says please enter any number from this range, but be sure it is better, it is lower than 32768. If you use the first command, spanning tree VLAN 1 root primary, it is kind of a macros, because what it will do is he will see the priority of the root bridge and he will set his priority 24576, because he will keep one for the secondary also. So you can say one is the primary, one is the secondary. So if you say spanning tree VLAN 1, sorry, VLAN whatever primary, he will choose a number lesser than the current one. So if the current root priority is this, he will say, okay, this is the current root bridge, this will be for secondary, you can say, so I will choose this one. That is how one step back it will take. I want this switch to be the root for VLAN 3. So I will say, okay, priority is any value 20480. No worries. 20480. Now, earlier, if I did not enter that command, but if I see now, show spanning tree, this is the person who is root for VLAN 1. This is the person who is root for VLAN 2. See, 005 is for VLAN 1, 006 is for VLAN 2, and 00E is me, and this is, I am the root bridge for VLAN 3. Getting the point? So in a nutshell, if I tell you, what did we do? Simply, we had three devices, 1, 2, and 3, and we wanted one device to be the root for VLAN 1, one device to be the root for VLAN 2, and one device to be the root for VLAN 3. So I did not do anything on the first switch for VLAN 1. So by default, Cisco is using per VLAN spanning tree. So you can decide this guy will be the root for VLAN 1. So you can change his priority for VLAN 1. If you want him to be the root for VLAN 2, you will say spanning tree VLAN 2 root primary or the priority. And if you want to have this the root for VLAN 3, that is how you can change him also. So Radia Proman, the developer itself, I saw her video. She says, I created the video. This spanning tree protocol is very stable, but sometimes it has an issue that it will block a link, but that is common spanning tree. So Cisco has PVST, so it will use all the links also. It's a very stable protocol, you can say. The only thing next to be seen is just assume a scenario wherein this is the root bridge and these two devices have calculated and they are stable. This port is in the blocking state. What if this port goes down? I had one port that used to take me to the root, but this upstream port goes down. Now is the chance, now is the time to turn on this link, because I had a path, I lost it. I should follow this path now towards the root bridge. This is my root bridge, for example, right? So I want to take this path, but spanning tree has some timers. Spanning tree, you can say, has these timers. These are the states: blocking, listening, learning, and forwarding. So if this device wants to bring up this link, he will go through these states: blocking, listening, learning, and then forwarding. This is the total of 50 seconds. If you see, blocking will be for 20 seconds, listening 15 seconds, learning 15 seconds, and then going to the forwarding state. So 20, 15, 15, and forwarding. So the overall, the total time of a link to come up is 50 seconds. And that is, you can say, is a total forward delay. So in an event of a link failure, the other device, see, data is not being transmitted, but BPDUs will be sent. How will these two devices talk to each other? They will not exchange data. They will not learn MAC addresses. But if the upstream, if a link is gone, I will generate a topology change notification, TCN BPDU, topology change notification, and I will inform him, my root bridge is gone. I need to turn this link on, but it will be double sure. It will be very sure that a loop never occurs. That is why these timers. So always we see that if we have one link going down, for example, I will shut down one link of mine. Let's say I have F0/2, configure terminal interface F0/2, shut this link down. Because this link is down, and now the convergence will happen. Let me take the another scenario, just a moment. So in a scenario wherein I have not changed anything, this device is the root bridge and this is my root port. What if I say enable configure terminal? First I'll say interface F0/2. I will shut my upstream port down. The moment I shut my upstream port down, assuming that there is a link failure, this link is not going to come up. It will transition through the states. Show spanning tree. See, this port is in the listening state. and then learning state, and then it will be in the forwarding state. After its timer is over, then this link comes up and this starts forwarding. So it will go through these states. Now it is in the forwarding state. See. So first blocking, listening, learning, and then forwarding. What are we learning? We are learning the MAC addresses so that our CAM table is populated, and then we will start forwarding the data. See the states in here. First it was down. It was earlier in the blocking state. Then the moment the upstream link goes down, listening state, learning state, and then the forwarding state. But in a high frequency environment, for example, see if I turn on this link, configure terminal, interface F0/2, no shut. If the upstream link comes up, this link will be off first so that the loop is avoided. So after that, this guy knows. So immediately within 2 seconds, this guy comes to know, okay, BPDU exchange happens, upstream link comes up, and I will block my link first, and then this is called convergence. The moment convergence is happening, data is not going to be transmitted on the links. And that is the reason people are very scared to change the cables. If you by mistakenly change a cable from one port to the another port, convergence starts happening, data stops transmitting. That is why people are scared of spanning tree also. You have to be very sure, and that is why we do not allow new CCNA people to touch our racks. If he or she goes to the rack and does something, it might go down. There are very big places wherein these events have happened. Getting the point? So everything is good in here. The only thing is the timers are a little, the timers are a little very slow, you can say. So these are your states, you can say. Blocking will not forward any frames. It will just listen and listen to BPDUs, you can say. Listening, port just listens to BPDUs, no loop sucker. And learning, what will it learn? Learn the paths, populate the MAC address, and then takes 50 seconds to turn on the link. Getting the point? This is per VLAN spanning tree, and by default we are learning, we have PVST on your Cisco devices. There are other flavors in spanning tree also. Actually, this is the common spanning tree, 802.1d, PVST, and we also have PVST plus. We will use some very good features, and we will use this. This is rapid spanning tree protocol, 802.1w IEEE standard, per VLAN spanning tree, per VLAN rapid spanning tree, PVRST, you can say. PVST we call it, PVST, and rapid PVST, actually we call it rapid per VLAN spanning tree. And this is MST, multiple spanning tree. See, if you say, now if you say I have 1000 VLANs, the thing we said, I have 1000 VLANs equals to 1000 instances in per VLAN spanning tree, right? So how do we, reduce the processing power? How will you reduce the processing power? Multiple spanning tree allows you to bundle multiple instances. So you can say my instance 1 till 300 will have so I'll say VLAN 1 to 300 will be in one instance. My VLANs 301 till 600 will be in second instance, and VLAN 600 to 1000 will be in the third instance. So even though I have 1000 VLANs, I am only running 3 instances. So better than PVST also, you can say. Multiple spanning tree is for advanced people. As of now we are in CCNA, but this is also a flavor. MST. So totally you have common spanning tree, per VLAN spanning tree, per VLAN spanning tree plus rapid spanning tree, rapid per VLAN spanning tree, multiple spanning tree. Getting it? Rapid spanning tree has fast timers. So instead of going through all these states, instead of going through blocking, listening, learning, and then forwarding, rapid spanning tree has the states of discarding. Again, discarding, and learning and forwarding are the same. So it is very fast. Usually it takes around 5 seconds to turn on the link. And how do you use spanning tree, rapid spanning tree? You have to be in the global configuration mode. See, on the switch, I go and I say configure terminal spanning tree mode question mark. If you want to run Cisco's flavor, rapid and per VLAN, then you can use RPVST. So here you can select, okay, spanning tree VLAN mode. Do I want to run per VLAN spanning tree, or do I want to run rapid per VLAN spanning tree? You can change the mode. This protocol will automatically configure the things for us. Okay, so in the next video, we will see how the features like port fast, root guard and all enabled. Let's take a break for now.